So this is example problem number 4. Okay, I've got no fractions, no products, can't really use the Pythagorean identity. And they're all about equal here in terms of what's going on. So I'm going to see if I can make the left-hand sides into sines and cosines, because I know that if I can make it into sines and cosines, then I'm going to be able to use the reciprocal identity and make it into secant and cosecant. And because of the quotient identities, I know that I can make these into sine and cosine. So let's go ahead and take this side of the equation only. So tangent x plus cotangent x. All right, so let me put my identities over here. Remember, tangent x is going to equal sine x over cosine x. So I'm going to plug that in here. So this is going to equal sine x over cosine x. Okay, and then cotangent, again using your quotient identities, is cosine x over sine x. So plus cosine x over sine x. All right, so now I've got fractions. I can make a common denominator and add my fractions. So I'm going to multiply this side by cosine x, and I'm going to multiply this side by sine x. I'm going to try not to end up with this too incredibly messy here. All right, it's kind of hard to, hopefully you can see here that this is a fraction. Okay, so let's go ahead and simplify here. So my common denominator, there we go, is going to be sine x times cosine x. And then in my numerator, I'm going to have sine squared x plus cosine squared x. Okay, next I'm using the Pythagorean identity, and we've talked about the Pythagorean identity a couple times here. So sine squared a plus cosine squared a equals 1. So I can replace this entire numerator with 1, and so then in the denominator I have sine x cosine x. Okay, now I really have the product of a fraction. So let me write those separately, because then it's a little bit easier to see. I have finally gotten pretty much where I want to be here, because the reciprocal of sine is cosecant, and the reciprocal of cosine is secant. So I'm going to go ahead and plug those in. And so now I have verified this identity, because I have shown that both sides of the equation are equivalent. Okay, now for example 5. So for example 5, I'm going to use secant x plus tangent x equals cosine x over 1 minus sine x. Okay, let's see. This one's kind of funky. So what can we do here? We're going to go ahead and use the right-hand side, because we can simplify that denominator. So I can make this a difference of squares. So I'm going to take this side only, and I'm going to write it down here. Okay, and to make it a difference of squares, I'm going to multiply the top and bottom by 1 plus sine x. Okay, so now that gives me 1 minus sine squared x, and then in the numerator it's going to be cosine x plus cosine x times sine x. All right, back to our happy little Pythagorean identity. So as soon as I see a 1 and a sine, or a 1 and a cosine, or a 1 and a tangent, and a 1 and a secant, or a 1 and a cotangent, or 1 and a cosecant, that's my clue for the Pythagorean identity. All right, so when I'm looking at this, we've moved this around a bunch of times, so we don't need either of these two at this point, because what I need is the original one that I crossed out. So I'm going to rearrange, and this will be cosine squared, in this case x, equals 1 minus sine squared x. So I'm going to plug in cosine squared x for my 1 minus sine squared x. Then copy down my numerator. Okay. Now I'm going to write it as a separate fraction. And this is always a good idea when you have something kind of that's looking a little complicated and you're not quite sure what to do with it next. Often if you go ahead and separate that fraction, it'll become more clear what you can do with it, which usually results in using some sort of reciprocal identity. So, all right, what do we have going here? Can we use a reciprocal identity? Is that going to help me at all? Maybe. Kind of hard to tell. Is there any way I can simplify? Well, yeah, I can simplify. So this becomes 1 over cosine x, and this becomes sine x over cosine x. All right, so now I can use that reciprocal that I was looking for. So 1 over cosine x is secant x, and then here I've got sine over cosine, and if I look at my quotient identity, sine over cosine is tangent. So yay, I've verified this identity because I have shown that both sides of my equation are equal to each other.